What's up?
Hey.
Okay.
We finished the quiz.
Brady's just that fast. We're already done, Jessica. Sorry. So, and we can't help you. So, see ya.
Hey.
Okay.
Where do we need to back up to?
Wait.
If we all
Hey,
get
Brady.
B.
Okay, I still need C on number 1.
Okay. So
Yeah, that's
C.
what we're working on.
So C. Did you solve your X and Y vectors so you know how fast it goes in the X and you know how fast it goes in the Y?
No, I solved an equation for T in A, and I solved a range equation for R in B.
Okay.
I'm not sure where you get the X and Y vectors.
So just use because we have 600 meters per second at 30 degrees, right?
Right.
So we can just make that a right triangle and solve for X and Y. And so our X component is 519. Well, our X component is 600 cosine 30. Let's see if I can make this work.
Hey, Brady. So you were saying that you multiplied the time that you found?
Yep.
by
Because see, my Y component is 300.
Right. So
No, it's going to go up 300 meters every second.
Right. So, okay. Oh, dude, I did not even realize. Okay. I'm sorry. I'm just an embarrassment. It's all right. We'll just pretend I didn't say it. Okay, guys.
You're good, man. Don't worry about it.
Sorry.
Okay, and then we go 600.
Almost 11 o'clock here. Starting to struggle.
30. 600. Times by.
So how does that triangle help us find C?
Okay, because now we can solve for time because we know that it has traveled 5,000 meters in the X component. So 5,000 divided by 519, it'll tell us our time because that's going to tell us how long it took the ball to get to 5,000. It's got to get 5,000 and it's traveling 520 a second.
Okay.
And then that'll give you your time, and then you can then multiply that by the speed in the Y direction. And that'll give you how high it goes.
So did you get time as 9.6?
Yeah, for my calculation, I used 9.62. I don't know.
So I didn't round it
Yeah.
all the way through. I just stored it in my graphing calculator, and I actually got 2,886.7. So I think, I don't know, I'd round up to 2,887.
Oh, let me keep all my digits then.
So yeah, because I just stored it in my calculator and it did it for me, and that's what it got. But so try and see if you get that. If not, we 2,886.
Okay, let me see. Let me pull that guy down.
It's the greatest
That's
height.
not right. 9. Two eight eight six 28868.
Yep. So round it up to 2,887, right?
Yep, that's what I get if I have all my digits.
Okay. Perfect.
All my digits.
All my digits.
I'm so tired.
So then this one.
So for part D, do you first take the derivative of r to find the velocity vector, and then set the velocity vector in the y direction equal to 0 to find, because like its greatest height is going to be when the velocity in the y direction is 0. And so like, that makes sense what I'm saying? Like you first find the velocity vector, and then its velocity is going to be 0 when it reaches its greatest height. It's going to go up and stop first.
Well,
like back down.
Yeah, you can. I know you can do that, but he gave us a formula that I've never seen before.
That I might have just forgot about it.
It's just your initial velocity
Okay.
times sine alpha, square all of that, and then divide by 2g. And I like that because I'm used to, like, I remember in physics doing what you're talking about.
Yeah, that's I'm talking about I'm talking about physics. Is what I'm doing.
But there was this super easy formula in the homework though. So
Okay.
So for D, did you get 4592?
I did, yes.
What? Hold on. I did not get that. Okay. What is that?
Okay, so let's see. Once you have time, what do you do to find the how high it will be?
So that's why we solve for the y component on that vector triangle, because we know that it travels at 300 meters per second up.
So you just times 300 by 9.6?
Yep, 9.618 or whatever we used, yep.
Yeah.
Okay. So you guys got 2886.75?
Yep.
Okay.
Okay, really quick. What did you get? I'm not getting what you guys got for me.
So is this how, let's see if I can get the formula. Did you get the formula like that? I know that might be backwards, but
Sorry, for some reason I was using the initial velocity in like the y direction for some reason. That's
yeah, so use your actual 600.
okay.
And
Sorry.
then sine of 30 is just 1/2, so it's really just 300 squared.
Yep.
And I don't know where that formula came from, because I've always used like inflection points or whatever, and you get your zeros or whatever.
Right.
But it was in my math lab.
Oh,
Homework.
that's convenient.
Yeah, it was nice.
That's cheesy. 5, 3. So did you guys round it to 4592?
Yeah.
Yep.
Oh gosh. It's okay.
So there's probably like, I mean, I know that we could have been doing derivatives and stuff to go from like acceleration and velocity and stuff, but in my math lab, this is how they did it.
Yeah, and the vectors make a lot more sense to me, at least with the other ones.
Yeah, I mean, this is how I always do it in physics, so
Yeah.
I don't know. For this simple of a problem, this is pretty easy.
So did you guys get 4591.84 for D?
Yep. And so we're 4592.
Yeah,
Okay.
just round it up for yeah. Okay, this one's a pain.
Find the velocity.
Hear that.
Find the length of the velocity. The length of the velocity of the length of that. Right? That's what we're doing for this one?
Yeah, sure.
So this one, you take the derivative of them,
Yeah.
and put it over the square root.
Oh, yeah, and then just do
Squared.
the unit vector.
Yeah.
Or like, yeah, find the magnitude. You divide by the magnitude.
I was just about to ask you guys who I'm like really hot right now in this room, and I was about to ask you guys. I'm like, are you guys like hot? I'm really hot right now. But then yeah,
You realize we're not
it
there.
makes no difference where I'm at right now. Anyways,
Just remember you have a camera on.
Yeah.
Yeah, I get that a lot. It's okay.
Okay, let's try this. Let's see. So,
Oh, you guys like ever just square part of something, but don't square the other part of something? Still put it within like a squared function that you haven't done. Do that.
what do you mean square part of something and don't
Like-
square the other part?
Like when you know whenever you have to do like the length of the, like you have to set v over the length of itself to get the like tangent vector. And so you have to do like this, like you have to square 18t squared plus.
Oh,
Like I'll square the t, but I won't square the 18. But then I still put it in.
oh, just do that. Yeah, I gotcha. Yeah, I've done that.
I do that all the time. I'm like, ah, shoot.
Gosh, what is 18 squared? Beautiful. Okay. So for the magnitude of the derivative, did you guys get 21 t squared?
Yep.
Okay.
Is that the square root of 441?
Yeah, it's 21. Yeah, that makes it nice.
Okay. And then
21 t squared. 21 t squared.
so for the unit tangent vector, I got 6 over 7i, 2 over 7j, and negative 3 over 7k.
So did I.
I got.
Yay.
7 minus 3 over. So you got 6 over 7, 2 over 7, negative 3 over 7.
Mhm.
Yep.
Sweet. Sweet, sweet.
And how do you do the length again? Isn't
So you do, it's the integral of your magnitude, basically.
Oh, yeah. Okay.
So integral of 21 t squared, right? From 1 to 3.
I think so.
I believe that's right.
Yep, be 21 t squared. So you,
That's the third power.
from 1 to 3. The integral is 21 t cubed over 3.
Yeah, but 20 reduced to 7.
Oh, I guess you could factor out the 21. But yeah, anyways.
Well, 21 divided by 3 is 7.
Oh, yeah, you're right.
So did you get, I got like 182.
That's what I got.
Yeah, I'm going to double check.
Let's see if I
3 cubed. Oh, 3 cubed. 27.
Yes. Oh shoot.
Yeah, I got 182 as well.
And then this is the horrible stuff.
Yes. This is what I use Chegg for.
And curvature?
Yeah. Well, yeah. Yeah, the plane curve or whatever. Those ones. Let's see.
I think kind of like what you said earlier. Really, it's just like doing all the math kind of takes me a second. You know what I mean? Like it's like, oh, I know what to do, but 20 steps to put in.
So this is one that's like actually kind of weird to me because if I do the derivative in my head, I never get it right. Like, and so I don't know what I'm doing with derivatives because I always have to use a calculator. But I feel like I should just be able to product rule all
Right.
4 of these individually. Does that make sense?
Right. Yeah.
So I'll do it in my head and then we'll see why I'm wrong.
Okay.
I'll stick it in my calculator in a second.
I think what really throws me off is when you're doing like the homework and it has you do this really long thing and the answer is like 1. That really
The ones,
grinds.
did you actually like the ones today where it was having you do like the normal vectors? Did you see how my math lab was doing that?
Yeah, it was.
It was like
super
20
complicated.
steps. 20 steps
Yeah.
to do an inverse, and all you had to do was switch the negative sign.
Yeah, that's a pain.
I had no idea what they were doing.
Okay, so let's add these together.
So I got the t thing equals cosine t plus sine t.
Got what?
Whoa, hang on, say that again. What was that, Jessica? I'm sorry, you kind of cut out.
What did you get?
Are you just solving for like t, or are you solving for v of t now, or what part?
I just saw t right there. I just got cosine t I and sine t j.
What I got.
Cosine t plus sine t, right?
Coats, bro.
And then n.
Hey, have you guys seen Stranger Things season 2?
So I'm sorry, what's that, Sawyer?
Never mind.
Okay, so n is just perpendicular to t. It's just inverse. So if t is cosine t sine t, then n is negative sine t cosine t.
Oh, cosine t.
Do we still have everybody? Yeah. Okay.
Yeah.
Oh, what was kappa? What was kappa? I don't remember what kappa.
K equals 1 over your magnitude.
Which that was 6t, right?
6t magnitude should be. See, I don't know. What did you get for V?
Wait. Was it? Oh gosh, guys. Hold on.
For v,
Yeah, I mean, like when you take the derivative of it, and that's called V of t. What did you get for
Oh.
that?
the derivative of the original equation,
Yeah.
cosine t, or wait, no, oh, sorry. It was 6t cosine t plus 6t sine t. That was my original derivative. And then
6t cosine t plus 6t sine t.
Yes.
Okay.
See, I keep getting, on the second part, I keep getting 6t sine t plus 12 cosine t.
For n?
No, for the very, for the r prime.
Oh, for r prime?
Yeah.
I'm just barely finishing it, so just let's see what I get.
Okay.
So I got my K of T, or I think I did.
What'd you get, Sawyer?
I got 1 over 6T.
Yeah, that's what I got.
6t. So
Because 6t is the magnitude. So what did you get for your derivative? For r prime?
I'm actually only just getting
You got-
12t cosine t.
What am I doing wrong?
Brady?
I'm sorry. Go ahead.
Oh, no. Sorry, you're still solving. Sawyer, what did you get for your r prime?
For R prime, I got 6T cosine T plus 6T sine T.
Perfect. And then you divide it by 6t, and that gives you
Cosine T,
the first part, the t of t or whatever. It's cosine t plus sine t.
correct. And
Oh wait.
so because when you're taking the derivative of R, right, the 6 sine T goes to negative 6 sine T. And then when you're using the product rule for the second part, the first part of it is the 6 sine T. Then you have plus
Yep.
6 cosine T.
So yes, you cancel and cancel.
Right, and then on the next part for the y vector, the same thing happens with cosine.
Okay, I got it.
So on the y part, so for the original equation r for the y component, do you have 6 sine t minus 6t cosine t?
Yeah. Yep.
Okay, so the derivative of 6 sine t is 6 cosine t, correct?
Yep.
Yeah.
Okay, and then the derivative of the next part, I keep getting 6t sine t plus 6 cosine t.
That
And
is
so
true.
my cosine t's out.
No, what you got is right.
You have to distribute the negative.
Now distribute the negative.
Good.
Yeah, so your
And that's what
cosines cancel out, right? Is that what you said?
Yeah, my
No,
things
hers-
don't cancel.
Oh, yours don't. Oh.
So like,
You should
So-
have 6 cosine t minus, and then parentheses, 6 cosine t plus 6t sine t. So it's
Like-
6 cosine t minus 6 cosine t minus 6t sine t.
See if you can. If I can get
Okay,
where you can
6
see it.
cosine t plus 6t sine t.
Are you
Okay.
following all, Jessica?
I got it. Yeah.
Okay, gotcha.
yeah.
Okay.
And those cancel, they'll simplify down. And so your r prime should be 6t cosine t plus 6t sine t.
Yep.
And then you take that and you do, so then that, with those, you can then find the magnitude. And the magnitude
Right.
is 6t, you divide by that. So then first part is just cosine t sine t.
So when we use those to get the magnitude, it's 6t cosine t squared, right? So then we end up with 36t that we can factor out
Yep.
multiplied by 1.
Wait. 36 t squared.
T squared.
Yeah.
Okay.
Because that will take the square root down to 6t. You need a t
Okay.
squared.
So our magnitude, our v magnitude should be 6t.
Yes.
Yep.
Okay. T.
What you were saying earlier, Sawyer, about forgetting to square both parts. You know, see, I do that a lot with like when it's 6x sine x or something. I do that a lot. I forget to square both parts.
I do that all the time. I'm just like, oh my gosh, like what is wrong? And then I'm like, oh, frick, what? Come on. Like,
So for vector n, did you guys get negative sine t and positive cosine t?
yes, ma'am.
Yep.
And how did
Okay.
you do that?
How did I do that?
Yeah, because all I
I
do
took
is swap and add the negative. And that's always
Well,
right.
oh. Well,
So
I'm
that
taking
one-
the derivative of t, and then I'm taking the magnitude of t prime,
Yep.
and then dividing t prime by the magnitude of t prime.
You do the exact same thing for n that you do for t to r.
Yeah, you do the exact same steps as you did to get t, but
Okay.
you use t instead of r.
It just makes no sense to me because it's a normal vector, so it's perpendicular, so it's an inverse. So you can just swap them and then
Right, exactly. Yeah, that's a lot easier than like trying to go through.
I did that
I
on
think-
every one of the homeworks and it was right. So
Yep.
Yeah, it works, but I do think. See, I feel like there was a homework that didn't work for me. Like I don't know because I don't know. It might always work, but for some reason I'm a little doubtful of it. So I would be a little careful. I feel like I hit one problem where it didn't work for some reason, but it seems like it should.
and
So how do you find kappa?
it's just 1 over your v magnitude, so it's just 1 over 6t, right?
Yep.
No. It's wait. It's
1 over the magnitude of what?
it's the magnitude of t prime over the magnitude of v. So,
Kappa.
Yeah, technically it's the magnitude of t prime over.
yeah.
Oh, sorry, what?
Oh, the magnitude of t prime over the magnitude of r?
Of r prime.
R prime, right. Okay.
Yeah, yeah,
So that's 1 over 6t.
Right.
correct.
Oh,
So
so
that-
that's your answer, 1 over 6t.
That's what I was saying. Where
Okay.
sometimes your t prime magnitude is not always.
Okay.
At least that's
Wait.
what I got. That's why it doesn't always. It's not always just the inverse. At least I don't know if that makes sense to you guys, but to me, I don't know.
Right. So you
Well,
guys
that
were
was-
saying,
Okay, let me go back. Okay, no.
so you guys were saying that there's a shorter way to do the homework? Because like I did it exactly like my math lab told me with all the like 25 billion steps.
For me, all I did on those norms is swap the spots and then make the first one negative, and I got them all right.
Yeah.
See how you just swap the
Oh.
sine and cosine?
Yeah.
Because that should work because it's a normal vector. We're looking for a perpendicular vector, so it should be an inverse.
Yeah, exactly. So yeah.
But now I am a little confused about k because I'm looking in my notes and I have it written down at one place I have written down just 1 over magnitude, and then I have 1 over magnitude times dt.
Yeah, that's what like he gives us the like actual equation is 1 over magnitude v times the magnitude of d dt whatever. Dt prime.
Yeah, I think it's probably always going to be 1, I would assume. So that's probably why he says that. But I think technically you use the formula where you go magnitude of t prime over magnitude of r prime. But I don't know.
But now I'm looking back at my homework and there's one where, so when you do it your way, Sawyer, do you still end up with 1 over 6t?
I do. Yeah, I still end up
Okay.
with that because the prime of t in this, or the prime of magnitude t prime. Holy cow, guys! Magnitude t prime in this instance is just 1 because you're going to be squaring a sine and a cosine, so it's going to end up being sine.
Yeah, just gonna be 1.
Okay.
But like for instance, if sometimes you're doing this and like within your normal vector, you actually have numbers with those sine or cosine.
Yeah.
That's where that would not end up being 1. It actually ends up being like 6 or 7 or some prime
Yeah.
number.
Because I'm looking at my homework here, and there is some that we had to multiply something there.
Right. Yeah. Exactly.
Okay.
So on number 1A, did you guys use like a formula, or did you, cause like I had a formula written down and I'm not like, I feel like a ton of formulas passed after, but like, did you guys do it a different way?
So I used
On-
the formula. I used
You used the formula?
initial velocity sine alpha over g.
That's what I did. Ones you did, you made a triangle and
Yeah.
okay.
Triangles for days.
So should we go over the answers?
Yeah, because I still have never gotten all the stuff right that we solved for. I still keep getting bad grades on these.
Yeah, they're always weird. None of us ever get the same, I feel like, but
Has anyone ever got 100 on one of these?
I did
Uh,
a couple weeks
yeah.
ago.
See, I still haven't even gotten
Yes.
an 80. And yeah, it's bugging me.
Well, yeah, that's the only one I got an A on. Everyone else has been either a B or lower.
I think I've pretty much got an 88 on almost every one.
I don't know. 1A rounded is 61.2.
okay.
1B rounded is 31,813 or 31813.
Okay.
1C rounded is 2887.
Okay.
And then 1D is rounded is 4592.
What I got.
Oh, wait a second. Oh, I've got these. What did I do? I solved for something we didn't need. C is supposed to be 2887.
Yeah.
Okay, because I have that for D. Maybe I just put these in backwards. And then D is height, so that's 4592.
Yep.
I entered these in there. Yeah, glad we checked.
Yeah, so A is when the projectile strikes. B is how far away it will strike. C should be how high overhead when it's 5 kilometers downrange. And
Okay.
D is the greatest height reached.
Okay. And I felt good about those.
Yeah, those ones are pretty straightforward, unless he marks us off for rounding weird, which would be absolutely stupid. But
Yeah, because I think we got that.
yeah. So then the next, so number 2, the curve's unit tangent vector should be 6 over 7I, 2 over 7J, and then negative 3 over 7K.
Okay.
Sawyer, is that what you got too?
Yes, sir. Yes.
And then the length of the indicated portion of the curve should be 182.
Yep.
Sweet. And then the last one. The last one should be t equals cosine t I plus sine t j. N is equal to negative sine ti plus cosine tj.
Okay.
And then k kappa should be equal to 1 over 6t.
Yeah.
Yep.
Now, here's a question for you. Do we need to regard at all the t is greater than 0 at the end of the equation?
So I just submitted it, and I got a pretty good grade. So I
Okay. Thanks for that help.
I'm sorry, I didn't. I was just like, okay, yeah.
I didn't. What the heck?
I didn't either.
I got I got part of question 1 wrong, but everything else was right.
I got part of question 1 wrong, but I got everything else right.
What? Yes. That's what I got. That's what I missed too. So I missed 1C. Dang it. Okay. So look here. That's so dumb, but
That's so dumb.
so dumb.
What is it supposed?
So how high overhead will the projectile be when it is
2,
5?
4.
So if we go, try this again.
Oh, we're going. Sorry, I'm yawning too much.
300.
Okay, so we store that there. Five.
Disagree. That's all there is to it.
What'd you say?
I disagree. Like, there's nothing wrong with what we're doing.
And then that's how long it's going to take. Yeah, yeah.
So I actually, just so you know, I actually used, like, I didn't use 520. I actually used 519.615, and I got the same answer that we put in. Like, I used a really specific number for this division.
So then that.
5 kilometers.
Sine 30.
Oh, nope. Nope.
Yep, I got 2887 again.
Yeah, that's what I got too.
Man, these are frustrating, but
Well, the last time I emailed him, he fixed it for me. So I don't know if you guys want to do that. They're like, hey, this is part B and go right and wrong.
yeah, I don't. It's weird. It's weird.
So can I ask a question on the chapter or the week 6 quiz?
Yeah, I haven't pulled mine up yet, and I was hoping maybe get to that this week. Did you miss some?
The only one I missed was number 4.
I haven't even looked. So it's under assignments, is that right?
Yeah,
And then what quiz?
week 6.
Week 6. Okay. Mm,
Oh, yeah. Yeah, I messed up this. Up maybe on like on number 3.
So which one did you miss?
I missed number 4.
Okay, I got number 4, right? Can we just start up at the top really quick?
Yeah.
So did anybody miss anything on number 1?
Let me go to my quiz. Sorry, I haven't even pulled mine up. Okay, so 215. Come on. Six.
In fact, I think we actually talked about these, the ones I missed, when we were talking about the shapes.
Yeah.
Yeah.
Because I got all of 1 right. We'll wait for Hayden real quick. He hurries up.
There, sorry. Yeah, I got one right.
Okay.
A and B. So
Did you get number 2? How about number 2?
oh, A, B, and I guess C too. 2 looks like I got that one. Oh wait. Oh. You know, it probably would help if I looked at the actual part that he graded.
Yeah, probably.
That might help. Maybe I didn't get those right. Okay. Okay, yeah. So I got, yeah, and I got 2 right. Yep. We're good there.
Okay, so on number 2, I missed the second one and the second to last one. So the second one, the 2x squared minus y squared plus z squared equals 0. What type is that?
Cone.
Just cone. Okay. And the x squared plus y squared minus z squared equals -4.
I got that that's a hyperboloid of 2.
Okay.
Yeah.
Okay. Now, on number 3, I'm not sure what happened. 3 points per blank. Okay, I just missed. It actually looks like I just skipped one. I don't know what I was doing. I don't see an answer on one. So on 3, it's E, then B, and then what's the third one?
The third one.
I got A and then C for the third one.
For the, wait.
Yeah, I just put C for the third one, but yeah.
I put A and C, but he didn't mark me wrong, so.
And what did you do, Sawyer?
So I just put A and I got it wrong. So so this is the one on number 3. I messed up. I messed up on 3 really bad for some reason. But on number 5, where it's basically the same thing, it just gives you the graphs, I got that one all right.
Okay.
I don't know why I messed that up. But
So number 3 is A and C or C.
I guess,
Yeah.
I don't know.
Okay. Okay, so number 4, find a vector such that an output vector always points away from the origin. So I just did a unit vector.
So what does that look like?
So I did vector xyz over the square root of x squared plus y squared plus z squared.
Over that and then y and then Z over that?
Well, so I wrote vector in vector notation with the less than sign, whatever. So less than x comma y comma z greater than over
Okay.
the square root of x squared plus y squared plus z squared.
Okay, so that whole vector over just that square root.
Yeah, just basically over its magnitude.
And you got that one right?
Yep.
Okay.
And then that's all I had. That's all I missed.
That's all I missed as well.
Yeah, the only ones I had issues with were I just flip-flopped some of the ones in 3.
could I ask what you guys did for, like, more just like 6, 7, and part A of 8. Like, I got them, but like I'm just not. I'm kind of curious, like, what did you guys do? How did you guys like get it? And if you wanted to share that with like, kind of what was your way of going about like this?
What one was this?
It's like 6 and 7 would honestly be helpful. I'm pretty sure that's what it was.
So 6, I just missed 1 point because I put bounds on Z when I should have put them on V. And when I should put them on V, or no, U. Sorry, U. I should put it on U. Because all I did was I said Z was equal to U, and then I set X equal to U cosine V, and Y equal to U sine V. Is that like the basic form for a parametrization for that? And then I just made sure I put the bounds. So from 2 to 4, and then V, your bound for your angle is always from 0 to 2 pi.
No, maybe I didn't mess that up at all.
And I didn't really go into much detail because I was just like, that's pretty straightforward. And so I just kind of wrote it, and he didn't. I mean, the only thing he marked me is I just put Z in the wrong place.
Okay. What about 7? Because I did mess up 7. Probably. Like I don't remember what I did wrong. I think that like how to
yeah, 7's tough.
like
I gotta
just got
find my work. Where is it? Let's see here. I had a scratch piece of paper that I did a lot of that work on. Let me see if I can find it.
Let's see who. Oh,
Did it end when?
let's see. Did
The call-
Hayden? Yeah, let me add Hayden again.
Oh, whoops. Can I ask you guys what you got on number 10 for the homework lesson 4?
I got for which part? For kappa or for rho?
The curvature. Okay.
Curvature, I got 1 over t.
Like, oh, okay. Oh. So for the radius of the curvature, you
Hey, sorry, Sawyer. I'm hanging.
no, it's okay.
Hey, so come to find out, I actually got 7 wrong.
Oh.
So what I did was I went back later and graphed it in Mathematica. And I don't know, really this one kind of confused me as far as how to like mathematically graph it. But I knew it was a circle, and you know the bounds are from, like, you know, the origin, you know, it's about 0. And then it expand, you know, the bounds are 4. So really it's like its radius is 4 or whatever. So I just kind of, and it's basically ends up being like a cone shape.
So I said it was an upside down cone, but I suck at drawing. Didn't draw that well.
He still marked it off for you?
I think so, yeah. And I mean, like, did you guys, so where it says like describe and sketch the surface, did you guys like make an actual equation for it? Does that make sense? Like an actual like XYZ equation, or did you just like sketch it out?
I sketched it out and labeled what kind of graph it was, and then I put some bounds on the y.
Yeah. So for y, would you just make it like y is 0 to 4? Or
So I did that y is less than or equal to 4, but greater than or equal to negative 12.
okay, see, like, yeah, okay. So like, where did you get that specific like?
So I know that 4 minus r squared, because that's the y component. Then you solve that for r, and you get r equals the square root of 4 minus y. Plug that in for the bounds that they give you. Is less than or equal to the square root of 4 minus y, which is less than or equal to 4 for y. Like I squared both sides 4, and then I divided by -1. It was less than or equal to y, which is less than or equal to 4.
Thank you. That helps a lot.
Okay.
So I figured out what we did wrong on the quiz.
Oh, yeah?
So we forgot to take in, it doesn't travel 300 meters per second every second. See, X isn't slowing down because we have no change in.
Oh, I know what you're
Y
saying.
is
Gravity.
Y has gravity.
Right. You don't have to worry about wind resistance. You take wind resistance out of the equation, but you still have gravity.
So you do what we did, but then you have to minus 1/2 gravity times squared. So
Okay.
I'll hold it up. Let's see if I can make that read. So you start with what I've got, and then you minus 1/2 gravity t squared. So we did the first half, but then we forgot to subtract that y direction is always slowing down.
I gotcha. That makes a lot more sense.
Okay.
I should have just looked back in my notes 2 pages because I did it in the homework.
Oh, that's fun. Miss something just like that.
I'm gonna get 100 on one of these quizzes. It's like my life goal now.
That's a good goal.
Yeah.
Okay. Now,
Hey, Jessica.
Yeah.
Can I ask you, what did you do for the radius of the curvature in that question 10 back on the homework? I'm sorry, I know.
I got P, the little Greek letter, whatever, equals T.
Okay. Oh, did you like that? Oh.
So yeah, so the radius of curvature is just the reciprocal of curvature.
Right. So did you? Oh, I'm sorry. Okay. So was your answer just T?
Yeah.
Okay. Okay. For a second, I thought you were saying like type that out, and I was like, where is the button for that like the letter? Okay. I was really confused. I was like,
When y'all gonna take the test?
I'm gonna have to take it tomorrow.
I'm hoping it's
Yeah,
as easy as
same
this
here.
quiz.
Yeah.
well, I have. Yeah. So is that how? I mean, is it going to be like this quiz then? Like, I mean, obviously longer, but it's going to have this stuff is what's on the quiz, like the past what 2 weeks or 3 weeks.
I feel like the partials and projectile motion, and then all these unit tangents, curvature tangent things.
Probably some parametrization too.
Yeah, probably, and that's like what I'm horrible at. I can never do those.
So when I looked at the study guide, it just said that the material it would be going over was week 4, 5, and 6.
Okay.
Oh, so that's not even 4, 5, and 6. Man, I can't remember any of that.
I know.
Yeah, parametrizing and then like graphing the polar coordinates and stuff like that.
Brutal. I'm trying to draw graphs without like some way to look at it.
Hmm.
Crazy.
Yeah, that's like the hardest stuff. Like I thought the last couple weeks were a lot easier to know how to do. Like if I could do the math, but
Right. I'm probably cram in the morning and then go take the test. So
Wait, do you take it at campus? No.
no, I'm taking it at a library. So
Yeah, that's what I do. I go like it took me like 7, 8 hours last time. It's like I couldn't imagine. I mean, I just worked on it until I felt like I figured it out.
right. Yeah, and it's gonna be if I was on campus, I probably wouldn't take it till Saturday, till like the last minute the testing center is open, and just try and go meet with a tutor and stuff. But
Yeah.
kind of hard.
Are you gonna try to meet with a tutor?
Sorry, what? Sorry, what were you gonna say?
Are you gonna try to go to campus like tomorrow and meet with a tutor or anything?
No, probably not, because the library here closes at 4, and I want to give myself plenty of time. So I guess I could run up in the morning and do it, but I'm probably just gonna
Yeah.
take like a couple pieces of paper and just write down everything that I need to know, and then just kind of go over it a bunch. Yeah. Wish we could take like note cards or something, or like a note card
Anything.
That'd be nice.
for formulas and stuff. Oh, that'd be so nice.
Yeah, I could use anything.
For real.
The hardest thing for me is always figuring out the problem, like what it wants you to do,
Right.
how to get started.
Okay, then let's try.
I'm trying to figure out question 9 again. Because I barely messed up on the first time today. Like, I just figured it.
I think I might jet and try and finish up some of these quiz corrections. So
All right, I'm gonna take off as well, unless anyone has any questions that I probably can't answer anyways.
thanks for the help, guys.
Thank you, guys.
All right.
Okay. Good luck on the test.
Yeah.
Nah,
You too.
All right, we'll see you.
I'm taking off. I'll see you guys later too.